Greetings, learners. Welcome to another math session. In this session, we'll be looking at the nature of roots. Okay, so if we can see the question that we're given here, we have the first one is 1.3. So 1.3, they want us to prove that this equation has rational roots for all rational values. Okay, so let's copy the equation here. It's what? It's 6x squared plus 2gx minus 3x equals to or minus g equals to 0, right? So the first thing that we need to do here, we need to write this equation here into its standard form, right? So we can see that we are having a quadratic equation. So we need to write the quadratic equation into its standard form. What's the standard form? The standard form, we know that it's what? It's ax squared plus bx plus c equals to 0. So we know this is the standard form for the quadratic equation. So let's write this equation here into its standard form. So, okay, so what we need to do here, we have what? We have 6x squared, and then we see that for x here, because we can see the coefficient of x is b. So for x, we have a common factor here, which is x. So we'll have what? We'll have 2g minus 3, and then this will be multiplied by x. So this will be the coefficient of x as we see from bx. So what is our constant? Our constant is minus g. Okay, so in this case, we'll have minus g equals to 0. Okay, so now that this equation is into its standard form, we can find the discriminant. So our discriminant will be b squared minus 4ac. So this is our discriminant. So what is our b squared? Remember, this is our a, this is our b, this is our c. So b squared is 2g minus 3. So 2g minus 3 is our b squared. So we need to square this because it's our b squared. Minus 4, what is our a? Our a is 6. And then what is our c? Our c is our constant, which is what? Which is negative g. Okay, so we can see that the discriminant here will equal to 2g minus 3 squared. We'll have 4g squared, and then this will have minus 12g, and then plus 9. Okay, and then negative 4 times 6 is negative 24 times negative g. So we'll have positive 24g. Okay, so the next thing, we can group our like terms. What are like terms? So we have what? We have 4g squared. Our like terms, we have negative 12g and positive 24g. So when we add those, we'll have positive 12g, and then what? Plus 9. Okay, so we can see this. We can factorize this. When we factorize this, we get 2g plus 3, okay, squared, right? So 2g plus 3 squared. So this is our discriminant. So we can see our discriminant here has a perfect square, right? So it means that the roots are rational, right? So we have proved that the roots are rational. Okay, so we can see it has a perfect square. Okay. And then going to the next one, 1.4. So for 1.4 is the same question as well. So in this case, we need to determine the values for m for which the roots of the equations are non-real. So we need to determine the equations for, the values for m for which the equations are non-real. Okay, so what we need to do here, we have what? We have 2m squared, mx squared equals to 3x minus 8. Okay, so the first thing we need to do, you need to write this equation into its standard form. We can see again, we have a quadratic equation. So we need to write this into its standard form. So we have 2mx squared minus 3x and then plus 8, which equals to 0. Okay, so now this equation is into its standard form. So remember the question they asked us to determine the values for m for which the roots of the equation are non-real. So for the roots of equations to be non-real, we know that the discriminant has to be what? Less than 0. So the discriminant of this equation here has to be less than 0 for this to be non-real. So the discriminant, let's find the discriminant of this equation. The discriminant of this equation, we know that is what is b squared minus 4ac. Okay, so b squared, what is our b squared? Our b squared is negative 3 squared minus 4. What is our a? Our a is 2m. Okay. What is our c, which is the constant, is what is 8. Okay. Negative 3 squared is what is 9. Then negative 4 times 2m is negative 8m. And then negative 8m times 8 is what? Is negative 64m. Okay, so we have found that our discriminant is 9 minus 64m. So we said for the values of m for which the roots of the equations are non-real. So for the roots to be non-real, we know that the discriminant has to be less than 0. So the discriminant has to be less than 0. What does this mean? We have the discriminant, which is what? Which is 9 minus 64m. So this discriminant has to be less than 0. So now we just need to solve this inequality. Okay, so we'll have what? We'll have 64m less than negative 9 when we solve this. So to get rid of negative 64, what do? We need to divide by negative 64 here and also divide by negative 64 here. Since we are dividing by negative, this sign here has to change, right? So instead of being less than, it will be greater than. So m will be greater than this, which is what? Which is negative 9 divided by negative 64, which is now positive 9 divided by 64. Okay, so our final answer, m will be greater than 9 divided by 64. So this is our final answer. Okay, we have reached the end of today's session. Please don't forget to like and subscribe. See you on the next video. Thank you.